Hello there, I'm Susan Wray, Editor-in-Chief of Physiological Reports, and it's my pleasure today to be speaking with Rachel Drew, an author of one of our papers. Her paper is entitled Omega-3 Polyunsaturated Fatty Acid Supplementation Attenuates Blood Pressure Increase at Onset of Isometric Handgrip Exercise in Healthy Young and Older Humans. Rachel, thank you for submitting to Physiological Reports. And could you kindly introduce your team to us, please? So who are the co-authors?
Absolutely. First of all, thank you for the invitation to talk about our paper with you. The authors on this study with me was Kevin Monahan, who's another researcher at Penn State Heart and Vascular Institute, and then Christine Clark, who is a medical student at the Penn State College of Medicine.
Thank you very much. I always enjoy hearing the teams and how diverse the teams are with stages of career and that. And I think it's always interesting for our readers to hear that. But even more interesting is, can you just give us a brief introduction to the background of your paper, Rachel? So set the scene for us. Why was this study needed?
It's well known that aging is associated with changes in autonomic nerve activity. There is an increased sympathetic activity and reduced parasympathetic activity, and both of those are linked with increased cardiovascular mortality. But it was important to look at some of the effects of aging on autonomic or cardiovascular responses at a time of acute autonomic adjustment, such as at the beginning of some type of exercise. So during things like isometric exercise, previous studies have shown that in healthy older people, their heart rate increase is less than healthy young people, and their cardiac output increase is also attenuated, but their mean arterial blood pressure increase is preserved in the older people compared to the young people. And it's thought that this is due to the increase in central arterial stiffness that happens with aging. So the interesting thing for us was to look at what effect would something like consumption of omega-3 polyunsaturated fatty acids have on something like this, because a lot of work has been done on consumption of fish oil and other products that have omega-3s in them. And there's been work that's shown that consumption of things like fish oil reduce the likelihood of people having a heart attack or other serious cardiovascular events. But there hasn't been much work done on the effects of omega-3 polyunsaturated fatty acid consumption on autonomic activity or cardiovascular responses in response to acute physiological stresses. That was the main issue that we wanted to try to investigate more. So we wanted to combine those different areas and effectively look at the effect of fish oil supplementation on the age-related cardiovascular responses to an acute physiological stressor. So we used isometric hand grip exercise, and specifically the onset of that exercise, because that's a time of acute reflex autonomic responses. So we wanted to see if fish oil could alter those responses and the mean arterial pressure and heart rate responses as a response to that. And we hypothesized that the fish oil consumption would attenuate the mean blood pressure increase in response to this onset of isometric hand grip exercise.
Okay, so that's partly why I really enjoyed reading this paper, putting together those two parts of the physiology. We're used to thinking of the fish oils and cardiovascular system, but you were moving that on now to another feature of physiology. So I enjoyed that. Were there any particular challenges, Rachel, in getting either the group of subjects together or the methodologies here?
The main challenge with this study was concerning the fish oil supplementation intervention that we used, because we wanted to use a fairly long duration, as far as physiology studies go, a long duration of the time that people would consume the fish oil. So previous studies have involved consumption of fish oil for maybe 4 weeks or 8 weeks, but we used 12 weeks of fish oil consumption. So the main challenge was to ensure that people were taking their fish oil every day, as they should have been, for the 12 weeks. So we employed things like having the subjects fill in pill diaries to say what time did they take their fish oil. We called the subjects every once in a while, and then we counted their fish oil capsules at the end of the study. And we have a group of subjects who help us with a lot of our research studies. So they were very good at taking their fish oil. But the quantification that we wanted to do to make sure that they were taking the fish oil and the fish oil was having the effect that we wanted was we did take a blood sample before and after their fish oil intervention to measure the red blood cell levels of the two main omega-3 polyunsaturated fatty acids, to make sure that they were really taking the fish oil that we wanted them to.
Very good, very good. Thank you, Rachel, for sharing that. How pesky as humans can be, eh? So, Rachel, can you just share with us what were the most important or the most exciting finding you had here? Were there differences or not between the young and the old?
Yeah, so the first thing was that we found that the fish oil consumption did attenuate the mean blood pressure increase in response to the onset of isometric handgrip exercise in the healthy older adults, which was what we had hypothesized to begin with. The reason we had hypothesized that was that if they had a greater level of central arterial stiffness due to their advanced age, we've shown recently that fish oil consumption can reduce that elevated arterial stiffness. So we thought that this fish oil consumption this time would have reduced their central arterial stiffness, which would have allowed their mean arterial blood pressure to increase, but it wouldn't have increased as much as it otherwise would have done. The interesting thing is we saw the exact same effect of the fish oil also in the young group. Their mean blood pressure increase in response to the onset of isometric handgrip exercise was also reduced. Now, young people aren't linked. They don't seem to have increased central arterial stiffness because they're otherwise healthy. So we thought that it might have been to do with the arterial stiffness. We didn't measure it in this study, but we thought it might have been linked to that. But considering the fish oil had the same effect in both groups, we're not sure that that is the reason behind that. It was a very exciting finding that it managed to have quite a profound impact on the mean blood pressure response to the onset of the isometric handgrip exercise. And it seemed to be that the attenuation in the mean arterial blood pressure increase was due to the attenuation in the diastolic blood pressure increase. So effectively, the diastolic blood pressure increase was reduced because of the fish oil, and because of the contribution of diastole to the cardiac cycle is more than systole, it seems to be that the fish oil consumption was having an effect on factors that control the diastolic blood pressure response to this acute exercise. The purpose of the study was just to look at the cardiovascular responses like blood pressure and heart rate. But the interesting question now is, what is it that the fish oil is doing that is causing these different cardiovascular responses? And other studies have shown that omega-3 polyunsaturated fatty acid consumption can increase the production or bioavailability of nitric oxide, or increase the production of endothelial nitric oxide synthase, which is the enzyme that leads to its production. So it may be the case that fish oil consumption is generally increasing the availability of nitric oxide, which is an endogenous vasodilator, in response to an acute physiological stimulus like isometric handgrip exercise. Their blood pressure increase may have been altered because their blood vessels were dilated more, so their blood pressure still increased in response to the exercise, but not as much because they had consumed this fish oil.
Dr. Drew, thank you very much for that. So clearly you've got plenty of new experiments to do, and we wish you well with those, and we hope also we might see the results and that data in another paper in Physiological Reports. Thank you for sharing with us, Rachel. Appreciate it.
Thanks very much, Sue.